Forget everything you have been taught about the queen as a ruler governing the hive. In bee biology, there is no monarchy. There is no conscious leadership. There is no emotional decision-making. Do you truly believe that a single individual consciously and autonomously manages an army of 60,000 insects? Have you ever, as operators, asked yourself why a high-performance genetic line in one biological system breaks production records, while in a neighboring system, at the exact same macro location, it drives the colony into complete economic collapse? Why do bees, at the very peak of the main nectar flow, when resources are flooding the ecosystem, suddenly stop nectar intake completely and initiate queen cell construction, even though there is massive empty space in the honey supers? The answer is not in her royal title. The answer lies in strict biochemistry and physics. In our first season, we precisely defined the external thermodynamic infrastructure of the apiary: macro location, wind influence, water availability, and spatial thermodynamic management. In the previous episode, we opened the internal demography and the rigid relationship between consumers and producers of economic surplus. Today, we penetrate into the physiological core of this machinery. Today, we demystify the queen. We will not observe her as an insect. We will observe her strictly as she actually functions in nature, as the colony's central biological engine. Her function is pure chemistry, ruthless mathematics, and a genetic algorithm that does not forgive operational errors. When we finish this analysis, you will never again view your production unit through the lens of amateurism. Welcome to Eterna Studio Beekeeping Channel. Let's get into the hard data. The biggest economic mistake a beekeeper can make is anthropomorphization, assigning human characteristics to biological systems. Traditional beekeeping worldwide is based on illusions. The queen does not rule. She does not issue commands to foragers on when to leave the hive, does not dictate to house bees when to raise brood temperature, nor does she decide when the colony will swarm. Her real biological function in the system is reduced to two strictly automated physiological processes. First, continuous emission of complex chemical signals, i.e. pheromone output. Second, conversion of protein input into biological mass, i.e. egg laying. She is a biological generator that continuously emits a chemical frequency within a closed network. Worker bees are exclusively biological receptors that detect and absorb this signal. As long as the concentration of this signal remains high, the hive's operating system functions in perfect order. The moment the pheromone signal strength drops below a critical threshold, the system automatically restarts through the process of supersedure, or physically divides through the process of swarming. Your financial success directly depends on how precisely you understand the frequency and power of this generator, as well as the genetic code that governs it. To understand exactly how a single organism controls the behavior of 60,000 individuals in total darkness, we must analyze its primary biological weapon, the queen mandibular pheromone, QMP. This is not a simple scent floating in the air. This is a highly strict chemical code composed of more than 5 complex acids and specific compounds. How is this chemical signal distributed across a massive demographic structure? The queen physically cannot make contact with every bee individually. As she moves across the wax comb, a so-called retinue forms around her, a strictly defined formation of 10 to 12 young attendant bees. Their role is dual. They feed the queen highly concentrated royal jelly, while at the same time, through their antenna and proboscis, they directly acquire the QMP signal from her exoskeleton. These bees then disperse throughout the rest of the hive. When they encounter other workers, through trophallaxis, the biological process of constant food exchange and tactile contact, they exponentially transfer that chemical signal further. This is the most sophisticated distribution network in nature. Here we reach a key diagnostic point that the global industry massively ignores. Why does a colony of 60,000 bees stop working and enter a destructive phase? Swarming is not some natural desire of bees to travel. Swarming is an acute system failure caused by a drop in pheromone voltage. The mathematics of this collapse is ruthless. The biological generator has an absolute physiological limit. The queen, within 24 hours, can synthesize and release only a strictly limited, finite amount of QMP chemical code. When your system contains 30,000 bees, the pheromone concentration per individual is extremely high. The system is absolutely stable and focused on surplus collection. However, when the demographic mass grows to 60,000 or 70,000 individuals, physical space becomes congested, and the distribution network collapses under load. Bees located at the absolute periphery of the system, on the outermost frames, simply stop receiving the chemical signal. The biological logic of the system at that moment is binary. No signal equals no queen equals we must urgently build a new one. At that point, mass construction of queen cells begins. Loss of chemical control over the periphery triggers the reproductive protocol. Your task as an economic auditor of the apiary is to prevent this drop through strict management of space and demography. Allowing the mass to exceed the generator's capacity means consciously losing total capex. The second essential function of the central biological processor is reproduction, but this process must be viewed strictly through the lens of energy mathematics. A queen of top genetics at peak season lays between 1,500 and 2,000 eggs every 24 hours. The total cumulative weight of these eggs in one day physically exceeds her own body weight. Imagine a biological engine that synthesizes more mass than itself every single day. For this generator to operate at such extreme speed, it requires the highest possible quality biological fuel. That fuel is exclusively royal jelly, and its synthesis directly depends on a continuous supply chain of fresh pollen. The chain of economic dependency looks like this. External macro location provides the primary protein input. For our clients in the United States and Canada, system input begins with massive blooming of almond plantations, California, early maples, Acer spp, goldenrod, solidago, alfalfa, and vast fields of canola in the Canadian prairies. In the United Kingdom and continental Europe, the economic start is dictated by hazel, corylus, hawthorn, crataegus, early willow, salix, and massive pollen intake from oilseed rape, Brassica napus, followed later by acacia, Robinia pseudoacacia, and heather, Calluna vulgaris. For operators in Australia, the biological generator is driven by endemic eucalyptus species, jarrah, carry, ironbark, macadamia, and large areas of wattle, acacia. Forager bees extract this raw protein resource and bring it into the system. Young house bees consume it, activate their hypopharyngeal glands, and synthesize it into royal jelly. They then feed the queen directly with this high-octane fuel. The queen takes that input and metabolically converts it into eggs, output. What amateurs fail to understand is that the queen absolutely does not decide how many eggs she will lay. Her egg-laying algorithm is a direct, involuntary physiological response to the amount of royal jelly she receives through the network. If drought stops eucalyptus nectar flow in Australia, or if a cold spring front in the UK prevents bees from flying to hawthorn, fresh pollen intake immediately stops. The glands of young workers begin to atrophy due to protein deficiency. The queen automatically receives drastically less food, and her metabolic engine reduces speed from 2,000 to 500 eggs per day, or stops completely. The generator inside the hive is not malfunctioning. The energy supply from outside has been physically cut off. To fully master this biological center, we must audit mating biology. An unmated queen is only an empty biological structure. During the first weeks of her life, she performs mating flights. This is the only moment in her entire biological lifespan when she accumulates external genetic material. She mates in flight with dozens of drones, collecting millions of sperm cells. This capital is permanently stored in a specialized internal organ called the Spermatheca. From that moment, she autonomously controls the fertilization of each individual egg. But this internal reservoir is strictly finite. Like any production asset, the queen has a lifespan and a depreciation rate. Many hobbyists proudly keep queens for 3 or 4 years, praising their longevity. In professional, process-oriented beekeeping, this is a self-inflicted economic mistake and systemically unacceptable behavior. Why must this generator be aggressively replaced? First reason, decline of Spermatheca capacity. Over time, reserves deplete. When the Spermatheca weakens, the queen begins laying more unfertilized eggs, drones. This is a total collapse of demographic efficiency. You are producing pure consumers, OPEX, instead of surplus producers. Second reason, decline in pheromone voltage. An older queen physiologically produces significantly less QMP chemical code. If you have an old, degraded queen in a colony of 50,000 bees, her weakened signal simply does not reach the periphery. A colony with an old queen is mathematically guaranteed to swarm and directly lose the entire spring honey yield. Third reason, immunological collapse. An older queen is significantly more susceptible to viruses and lacks the physiological capacity to maintain adequate brood renewal under acute stress conditions. For maximum economic yield, this biological generator is replaced every year or absolutely no later than every second year. Keeping an old queen to save money ultimately costs you 30 kilograms of unrealized honey profit by the end of the season. This is pure ROI, return on investment analysis, that must not be ignored. If pheromones are the communication network and ovaries the production matrix, then genetics is the operating system dictating how this machine behaves in space and time. There is no best genetics in the world. There is only genetics synchronized or completely unsynchronized with the external thermodynamics of your location. Scenario A, explosive algorithm. Italian bee, Apis mellifera ligustica, and other Mediterranean lines. This genetics is strictly programmed for a fast, explosive early start. It reacts to the first sunny day. The queen immediately raises egg laying to the biological maximum. When is this economically profitable? If your systems are positioned in California and you are preparing for almond pollination in early February, or if you are targeting early massive flows on canola plantations in the USA and Australia, this algorithm will deliver a huge demographic mass exactly on time. But when is this an economic disaster? If you are located in the cold prairies of Canada, harsh European mountains, or rainy regions of the United Kingdom, where spring temperatures oscillate aggressively, this explosive queen generates a massive area of open brood. When sudden cold hits, the workforce physically cannot cover and thermoregulate that volume. The colony consumes 3 times more energy trying to save the brood. Result: chilled brood, acute nosema outbreak, and total biological collapse already in April. Scenario B, conservative algorithm, Carniolan bee, Apis mellifera carnica, or dark European bee, AMM. This genetics has built-in defensive code for surviving long winters in Canada and Northern Europe, and deceptive spring fluctuations in the United Kingdom. It conserves energy extremely efficiently. The queen does not initiate massive egg laying until fresh pollen intake becomes absolutely continuous and temperatures stable. If rain stops flights for 3 days, she immediately reduces egg laying to protect internal reserves. Economic advantage: minimal consumption, OPEX, during winter, and high survival rate. Your operational task is not to buy an expensive queen from abroad. Your task is to secure a biological generator whose genetic algorithm perfectly reads the meteorological data of your specific microlocation. Integrating aggressive Mediterranean genetics into harsh Canadian or Scottish climate zones is equivalent to implementing a system without sufficient energy capacity. The system will collapse. An economic auditor of your apiary, your ultimate goal is peak synchronization. In previous reports, we established that the biological cycle requires 21 days from egg to worker emergence and an additional 21 days of internal work before she becomes an active forager. Total, 42 days of investment. Calculate backward. If your main profit flow begins on May 10, whether it is acacia in Central Europe, tupelo or clover in the USA, canola bloom in Canada, or eucalyptus, jarrah, in Australia, the bees that will physically extract that resource must be laid as eggs exactly 42 days earlier, around March 30th. In that precisely defined time window, your biological processor must operate at 100% capacity. Every egg laid between March 25th and April 10 represents your future pure profit. Conversely, Every egg laid during the main flow itself is pure operational cost, OPEX. That bee will not physically reach foraging stage in time, while as a larva, it will require aggressive resource consumption and over 100 feeding visits per day from nurse bees. Elite operators know how to restrict this generator, using queen excluders, once the flow begins. This frees thousands of bees from brood rearing and redirects them directly to nectar collection. That is running a biological system at the edge of maximum production. Bees are perfect internal analysts of their own system. When their detectors identify that the generator is failing, they do not immediately swarm. They activate an internal safety mechanism, Supersedure. They raise 1 to 3 queen cells in the center of the comb. This is biological perfection, but as a professional, you must never leave your profit to randomness and automatic safe mode. Your role is proactive maintenance. To summarize the data, the queen is not a leader. She is a chemical generator. She does not make decisions. She only reacts to logistical input of pollen and nectar availability. Her genetics is an algorithm that must be fully compatible with your geographic zone. Her age directly dictates the strength of the chemical signal, and the decline of that signal mathematically means chaos and swarming. Your task as an operator is not to constantly open the system and visually search for the queen. Amateurs waste hours trying to find her with their eyes. A professional auditor reads her functionality through the product of her work. If you detect a compact, geometrically correct brood pattern on the comb without gaps, your generator is working flawlessly. Record the parameters and close the system. If the brood is scattered, full of drone cells where they do not belong, and bees exhibit nervous behavior, a sign of pheromone deficiency, the processor is malfunctioning and urgent intervention is required. The efficiency of your hive is purely a reflection of the precision of its genetic code paired with your analytical competence. Beekeeping is not observing flowers. It is management of biological algorithm. Now, I demand your data in the comments below. Do you know exactly, genetically, and precisely which line you keep in your apiary in the USA, United Kingdom, Canada, Australia, or Europe? What is the average depreciation cycle of your queens? And have you ever recorded swarming caused exclusively by queen age? Your field data is the foundation of our global analytics. If this mathematical approach changes your operational paradigm and protects your capital, leave a like and make sure to subscribe to the Eterna channel. In the next, episode 22, we raise analytics to the global macroeconomic level. We will analyze a real field battle. Global auditor, location economics and opportunity cost, complete analysis. Prepare to dismantle trading illusions. Think systematically, measure precisely, operate with data, not assumptions. See you in the next episode.